Hi, I'm Alexander Phillips, and today I will be giving you a briefing on our proposal to replace the B-52 bomber with a new strategic bomber. So the problem that we're finding in the Air Force is that the B-52 is an aging aircraft fleet. It's exceeded its service life by about double. It started out planned to be a 10,000 flying hour aircraft. It has surpassed that, where most aircraft are about 20,000 flying hours per aircraft. It's been in service since 1954 and has served many roles, both conventional and a strategic bomber role. Currently, the aging fleet is possibly several negative side effects to our stakeholders, which would be U.S. citizens and our U.S. military as well. One of the biggest ones would be loss of national security. As the B-52 ages and gets older and older, it's harder to maintain, it's harder to perform that mission of nuclear deterrence. The inability to fight modern adversaries. In our last several wars over the last several years, we haven't really had to fight technologically advanced adversaries. So we come across an issue if we ever have to fight a world superpower or anyone with technological capabilities, we're really going to struggle fighting them with such an aging aircraft platform. And that loss of mission effectiveness is very crucial. Maintaining that mission effectiveness is very crucial to our military being carry out its mission. So some of the problems that makes the B-52 tough as it gets older is the operational cost. So currently the B-52 has an annual flying budget of about $2.1 billion, and that was in 2015. It's grown some since then as well. So that's a 10% increase in flying hour in the budget per year. Now, why that budget is increasing 10%, we've also been reducing the amount of hours the aircraft has flown. So we've reduced our hours flown by about 47%, but the cost has risen about 60%. So per hour, the B-52 is the most expensive aircraft in the United States Air Force, in the military in general, all branches, to fly and operate per hour. So some of the solutions that we evaluated in this proposal, some of these have been tried before, such as replace the engines. So we looked at replacing the engines with new, more modern engines than the ones that they were previously replaced with. They currently have the T533 engines in them. We'd replace them with the Pratt & Whitney engines, which would give us about 4,000 more miles in range and hopefully reduce some maintenance costs, although there's no real data on how much that maintenance cost will be reduced. But that's one of the most expensive upgrades that we can do. If you notice this chart right here, these are some of the B-52 modernization costs that we've done in the last couple decades. They're roughly about $11.9 billion in total upgrades that we've done to try and keep this aircraft modern. That yellow part of the pie chart is the actual engine upgrade. So as you can see, that is by far the most expensive upgrade that we've tried to do to the B-52. And that's including avionics upgrades as well as communication upgrades and some other weapons upgrades that we've added as well. One of the other solutions we looked at was implementing new maintenance strategies. So the positive side for implementing new maintenance metric strategies would be it takes almost $0 to update and change the way we focus maintenance metrics as far as what's going wrong with the aircraft, how we can predict when things will go wrong in so many hours, and take care of those in some of our home station and major inspections as scheduled maintenance and planned maintenance rather than unscheduled maintenance that's really hurting the B-52 now. Another solution we looked at was reducing aircraft flying hours. So by reducing aircraft flying hours, we put less stress on the aircraft, hopefully have less maintenance problems, less time to actually fix the aircraft, and that would be one of the positives of reducing aircraft flying hours. However, but by reducing aircraft flying hours, our cost per hour rises with the B-52, as well as a reduction in mission effectiveness. So if we're not able to train, we're not able to fly because it's too expensive, ultimately that's an ineffective aircraft in our fleet. We also took a look at possibly reducing the conventional mission for the B-52 entirely, not even having a conventional mission. And by conventional mission, we mean putting standard explosives and warheads on targets, so a non-nuclear mission, and just moving the B-52 to strictly the nuclear deterrence mission. That would drastically reduce the hours, but it would also create a vacuum in which other aircraft frames would have to fill that void and fill that mission in the Air Force. So that's still going to require additional money and funding from other areas within the Air Force to pick up the slack of the B-52 only operating in a nuclear mission. And then our last solution we looked at was entirely replacing the B-52 entirely with a brand new strategic bomber. So a brand new strategic bomber has some benefits, it also has some cons as well. So the biggest problem with replacing the entire fleet with a brand new aircraft is it's very expensive and time consuming. We've had problems with other aircrafts that we've tried to launch and put into service, and this poses a threat to be a difficult option as well. However, if we're able to overcome those issues, the benefits of replacing the B-52 entirely far outweigh the negatives. That's why we think replacing the B-52 would be the most efficient and effective solution. By just upgrading the B-52 and keeping it in service, we're just kicking the can down the road, so to speak. So implementing our new strategic bomber, we've learned some things with the F-35 and the F-22 program. The F-35 program, for example, the F-35 program went approximately $320 billion over budget, as well as took 23 years to finish production of the first initial order. And some of those F-35s are still not fully mission capable at this time. A large part of that was due to the fact that we used concurrent manufacturing. And concurrent manufacturing is basically the F-35 was produced, tested, and put into service before it was completed its testing and design phases. So while the F-35 was active, it was also being updated and new changes were being done to manufacturing. At the same time, F-35s were going into service. So we had problems keeping the ones that were produced fully mission capable, and then there was also a backlog in the manufacturing process because we were constantly updating and changing on the fly. So with the new strategic bomber, we are not going to use concurrent manufacturing. Instead, we're going to focus on a staged manufacturing process. That staged manufacturing process is going to include several different areas and stages that we are going to focus on. Those areas are analyze, design, test, and then training and production would be our last phase. So during our analyze phase, that's when we gather our pilots, maintainers, subject matter experts, leadership, and all the stakeholders within the Air Force who are going to be affected by this change and who have any kind of subject knowledge to lend to the production of this aircraft. During the analyze phase, we gather all those minds together. We decide what the operational capabilities of this new strategic bomber need to be. Once we identify those strategic abilities, hey, it needs to fly this far, it needs to be able to carry this much weapons, we need stealth capabilities, radar jamming capabilities, whatever it is we identify in that analyze phase, we're going to plug that into what we request in that new strategic bomber. So that phase is really just like our brainstorming session and deciding what the aircraft is going to be. During our design phase, this is when we actually design and build the aircraft for testing. So during the design phase, our mock-ups, our samples, our prototypes, all that stuff that we identified in the analyze phase is going to be included into that design phase, design the strategic bomber, and then we move on to our next phase, our test phase. So test phase is going to test the strategic bomber and make sure it's meeting all our operational capabilities that we need, as well as our manufacturing requirements that we're going to need for this aircraft. Once we finish our test phase and we have identified how we're going to manufacture the aircraft and how we are going to build it and what features to put into it, and we've gotten all the errors and kinks out of the system, we then move on to our training and production phase. So training and production are going to happen concurrently. We're going to train our pilots, we're going to train our maintainers, we're going to train our personnel, support personnel for the strategic bomber. At the same time, we are producing and shipping out our new aircraft. Now during these steps in the phase, evaluation is present during each phase. So during the analyze phase, and we move on to the design phase, during the design phase we notice, hey, there's some capabilities we should have added into this, we can reevaluate that and go back to the analyze phase. So at any point we can reevaluate where we are, move around within the system, and then continue on where we were. So if we run into any issues during testing, we can go back to the design phase, restructure our design, go back to the test phase. So we're always evaluating during each phase of this implementation process. So our solution effectiveness, how are we going to measure the effectiveness of this new strategic bomber? Well, there's several categories we need to look at. First off, it's going to need to meet all required operational capabilities. If this aircraft can't do what we're asking it to do, it's a failure right off the bat. All right, it has to be able to perform under operational conditions. Then we're going to look and see the timeline that we are able to complete this project. So right now we want to build about 25 bombers per year over 10 years, which will meet our initial order of 250 bombers, which can replace the 100 aging B-52 aircraft that are currently in service. We're also going to be looking for no cost overrun. So we're setting a budget of about $400 billion for the first 250 aircraft. That puts it at about $1.6 billion per aircraft that is produced. So our strategic bomber proposal today took a look at the aging B-52 fleet. We talked about how long the B-52 has been in service and why it needs to be replaced. We looked at the operational costs of the B-52 and why it's so expensive to maintain and fly. We also evaluated the possible solutions we looked at before arriving to try and implement the replacement of the B-52. And then we talked about our solution implementation and measuring success. So we want to implement that solution using our phases, not concurrent manufacturing. And then we want to make sure we're hitting that $400 billion 10-year timeline for 250 strategic bombers, as well as being able to reach all our operational capabilities. That is the B-52 replacement proposal, business proposal.